Good evening, ladies and gentlemen. Thank you for giving me a voice. My topic today will be showing how the fuel cell for hydrogen problem is solved in Brazil. The work will be cited today on the lecture will be two. First, on SSM is a number by Professor Cordaro from Mechanical Engineering University in Sao Paulo, entitled Electricity and Hydrogen Production by Cogeneration System Applied in a Fuel Station Ratio Energy Analysis of a combined solid oxide fuel cell and internal steam reforming model, and another article for basic model of hydrogen production is for storage. The storage is based on hydrogen storage in depleted offshore gas field in Brazil, potential and implication for energy security by Professor Maria Nachota, also from Sao Paulo University, and this is published in a recent number of International Hydrogen Energy Journal, International Journal of Hydrogen Energy, and in this case they were telling how much that find in this number the change of energy. From 2000 up to 2001, the 75%, 89% were coming from hydropower. Now the change is electric by 30% and 11 to 13 by gas, and increased, and only 54% is today by hydropower, 130% for sun and fuel cell, sun and wind power, and they found has idea to store the hydrogen in the depleted gas shell on the side after gas fields depleted to store, and thus they wanted to find fast method for changing hydrogen into electricity and generation by electrophoresis. Therefore, they combine a system for electricity, and now are 4,000 hydrogen stations in the Brazil in different cities available. They are the most appreciated wanted to made by solid oxide fuel cell idea that were made because recently we have big bioethanol experience, and a bioethanol for different biofuel tank station, and have to have very widely developed steam reforming. Therefore, to use steam reforming, recently used a system for making suitable temperature conditions for working as solid oxide, because solid oxide is making the electrodes of lanthanum or nickel in high temperature, 9 to 800,000, 1,000 degrees, where it's easier, and electricity water splitting is much more efficient. And this is using this electro-tunnel steam reforming facilities to make electrolysis. So they just, instead of making, for example, for ethanol, which is also a very good idea, the idea is to make the water. Their nomenclature is going to capacity of volumetric flow, fluorescent diffuse, electron produced, further constant, and molar temperature factor. There is several points: electrical chemistry, stoichiometry, and several combined heat and power. So how to this making in these science, in these facilities, and we know that hydrogen is perfect and use hydrogen power is perfect that can overcome carbon dioxide and over emission, which provides us to greenhouse effects. Therefore, we have thermoelectric also fusing from fossil fuels that represent nowadays 25% of national electrical National Fuels Policy, which is supported in 2021 by hydrogen policy that states that to 2035 they will have mostly only generation of hydrogen for renewable energy. This case that Brazil the policy determines propensity and decentralization diversification, especially in use of green fuels. Brazilian ethanol stands as biomass product for reducing or even suppressing carbon dioxide emissions, since agriculture consumes carbon dioxide during the growth of sugarcane. And finally, as the fourth aspect refers to future and growing demand for electric energy service to electric cars, which those cars could be provided with batteries or hydrogen fuel cells. The electric car could be used for urban shorter distances as well and long roads considering borders of electric car, which are developed right now. Secondly, the adaptation of fuel station for ethanol biofuel is presented or to match for aspects primary use. The research comprises the broad approach of insight, and first we have several ideas. First is accountable reports which produce types of business established threatened for emerging or ethanol production to the hydrogen, so shifting these compounds, and this gives the research space of analyzing adding ethanol reform to hydrogen using of fuel cell. Well-defined logistic of supply and establishment near the consumer. Applicable distributed decentralized generation for the diversification of electrical production. Micro diversification regarding the purposes of fuel stations. Decentralized storage hydrogen. Ethanol is transported instead of hydrogen for being more favorable. The expansion of the distributed electricity market. Thus, we have briefly situation and fuel station model to use these ethanol stations. The fuel electric cells and battery electric vehicles and plug-in hybrid vehicles, such electric vehicles need a correspondence infrastructure to order needs. Thus, hydrogen refuel stations exist in California, Japan, and Germany, which not have some experience in hydrogen transportation and gas. Hence, actual fuel situation in Brazil territory is good available to ethanol fueling. Therefore, we need to transform this. The Brazilian needs to transform these ethanol stations into hydrogen stations. So they think just to transfer ethanol or hot water into hydrogen by this solid oxide fuel cell, electrolysis cell. So this is the molecular use determines that hydrogen gas for supply needs to be the capacity tag of 3 kg to 5 kg of hydrogen. And shows the schematic of the hydrogen. The reformer ethanol is going to, with steam, going to solid oxide fuel cell and then generating electricity or by proton exchange membrane fuel cell, but is less efficiently to the pressurized cylinders. The admission of water and ethanol is going to this reformer, so both would be from steam and ethanol hydrogen combined. So big two values are used. The thermodynamic electricities, admission of ethanol, cleaning for properties as well as water and air, and ethanol with steam is reformer and going to mixture to the solid oxide fuel cell and obtain electricity. And such case is developed for hydrogen production. This case is important because we have whether electricity produced as a product of very because depending on conjecture of context use, demand may be favorable. The simultaneous production of electricity and hydrogen allows for the possibility of balance of terms of profits, economic value of commercialization of both products. That's the structuring of the model of two cells, one solid oxide fuel cell and polymer and protonated membrane fuel cell provide the immediate supply of electricity. Use proton exchange membrane fuel cell. This is less than 1 minute, producing balance hydrogen. Thereby, electrification is outstation where possible, allowing the use of model with an approach directly solely to hydrogen production. Additional stage of electrolyzing can be also added to the model to the excess of solid fuel oxide fuel cell. There was some aggregation, so acid, electricity, and hydrogen, and this reformer going to analytic. This node electronic medium is for solid oxide, and this anode is going hydrogen production and a cathode oxygen. So similarly, the estimation application of axis. This is the idea of working. In case of there are two versions where this electron medium is wider or less, and in case of big energy reaction, so 3 to 1, the case demand of higher proportion was the most efficient according to this analysis. The analysis was by informer Homer algorithm made. This is to make profitable make production of fuel and hydrogen in case of specific modify. And we have as steam reforming, so ethanol if by water, this produce monoxide and hydrogen. So it's simpler than in case of methane. So this requires is, and in case of is exothermic reaction, while the water shift is more endothermic. So this is favorable because it gives more energy than is depleted. So it's more fashionable. So this shows that they have idea to use existing for better working, and carbon monoxide wouldn't be double. So this is the idea which makes the Brazilians to overcome and overcome needs of hydrogen and overcome difficulties and low carboning, and thus ethanol requires less energy to be split into hydrogen than water. So it's much favorable to make it wet. There are some calculations also using electrical, chemical, and sophisticated. So this provides long-term and good idea how to change these two things. And thank you very much for listening to me.